No, not ceiling. Floor plan. We need to create another floor plan for level 1. Yes, we call it firefighting. Firefighting. Yeah. Level 1. We've done level 2. Okay, so these are level 1 here. So I think the filters are not working well. Okay, so let's go to, I can't find the HVAC because I want to use this to know the area or to know the tag. Don't know why it's not showing. So let me go to annotate. Let me say room tag. Still not showing. Room are not correctly visible in this view. That means switched off somewhere. Are you with me? Hello? Are you with me? We are trying to call up the names of the spaces and their area. And I know that it has been done before. Let me try and analyze space separator spaces. It's already there, but why is it not giving? I might need to just do this thing. Place spaces automatically. Okay, so after creating these spaces, I'll go to name it. Yep. Okay, we should do coordination. Okay. So after this, we are going to do coordination. Okay, no problem. Okay, I think we are now good with the spaces and the name. Okay, so conference 2. People are like, which screen are you seeing? I want to duplicate this. I want to extend this screen. So I'll be saying it's not possible. It's possible. I can take this one out and drop it somewhere. Okay, so let me just conference 2. Conference 2. Level 1. So I want to put my sprinkler, which is my AB sprinkler, this one. Ooh, sprinklers are not showing them. Right. Z elevation. This one 3000. Okay, I think it's the elevation. So Control C. This one should be 2. This one, I think 2. Entrance 1. We are not putting anything here. Stairwell. We are going to put something in the stairwell, but not now. What do you think we can put? What type of sprinkler are we putting at the stairwell? Oh. What type of sprinkler are we putting at the side wall discharge? Yes. So we are still going to do coordination because of the ceiling elements. You know, we are not the only one using the ceiling. We have lights. We have what again? We have HVAC as well. So we are going to make sure. Is what? Is passing through the ceiling. That one is not surface now. It's not on the surface of the ceiling. It's inside the ceiling void. I'm talking about what you can see in the ceiling. I just did this one based on our 21 square meter. I had not check that schedule again. It's wasting. I don't want to say it's wasting my time. This one is 12, Abby. You've seen it. Yep. We can just align. Let's do that. It will be the same thing. We can. We can copy now. Why not? It's allowed. Why you know how to copy? Okay, so make 2. Abby, already do it. Okay. I can highlight everything here. Come to the filter, check none, use sprinklers, then copy. You copy like this, come to level 2. Okay, this is level 2, come to level 1. Then paste align to current view. So it has pasted. So I want us to say something. It will. That we will do it. We'll do coordination.
I think we not affect coordination.
Coordination.
Yes,
yeah, that's what I'm saying. Did you not see it? We are still going to. We are going to. No, it's not going to. We are going to move around. We are going to move around. Move it around.
Will it still be standard based on the requirement by
Well, it will still be because we have a lot of constraints in this industry as per architects, other disciplines, especially lighting. I have issues with lighting. Honestly, they want to always take. They always want to take the video. Even HVAC sometimes. Yeah, that's what we normally have coordination. But if it's not affecting functionality as per the areas, we can still move on. But if it's necessary that it should be at the middle, then maybe HVAC can move a little bit for us, or we can find a way around it. We can take it out to do something. So I think we are good to remove the space, the coverage, so that we are going to have the space of the sprinkler alone now, so we can now coordinate and come. Select similar entire project, then remove this, then apply. So this is it. So I want to tell you, I want to put it to us that our sprinkler should have a distance to the wall that is consistent. This to this place too should be consistent. So we are using 225 and 3,225. Now let me go to this place. You cannot be doing. Look at it. This is very wrong. Look at it. We have 295. So what I can do here is move this. Move it to, let's say, let me say 3,000. So every other thing here to move. So I can just align. I can align everything on a straight line. Align this to this. I'm not sure this is passing on the. Let me just do DI. This to this one. This to this. And this to this. Just leave down. Just leave down. Is it 30? Okay. Sorry. I thought you were talking about the spaces to the middle. No. I thought you were talking about these ones here. I was trying to coordinate the one around the perimeter so that it will be the same distance to the wall. Okay, I think we are good at it. So if this 225, I should maintain 225 here too. I mean, I'm not aligned. 2255. This is more of moving around. This one I don't consider this one as engineering.
Actually, it's not.
That's why the calculation aspect of it, which you actually need. That's why I said firefighting is a lot of reading, because now I notice, I just read it that I just got to know that if you are doing a building more than 1, 2, 3, 4, 5, more than 6 suspended floors, more than 6, you should have 2 dedicated risers for sprinkler. From ground floor, yes, from ground to 6, 1, then from 6 to 12 to, let's say, 12. That's suspended floors. That's G plus 6. If it's more than G plus 6, then you must have 2 dedicated risers for the sprinkler. Do you understand?
More than 6. What did it say?
Yeah, you have one for the G to 6, then you have one dedicated for the 7. Do you understand?
Because of the pump pressure.
I think so. They have their reasons. It's a standard.
It's also the reason.
They get for
Just because sometimes now also you bring back this thing.
you have to know the reasons. Yeah, you're right.
I'm very sure where you got the permission for it's not the place I want to do.
It's not even that all. It was one person I was working with just told me that. Riton, please remember to separate those things because the standard in the UK now states that you should have. You understand?
It's not the plan.
But it's still working. It's still on the same pump. Oh. But you can decide to separate the pump anyway. You can decide to separate the pump. So that is this about that drafting, making everything to be aligned 3,000. This one to let's make it 3,000 from here to this place 3,000 from here to this place 3K. So one thing about I don't like about these things is that you cannot select everything like this. I just say everything at 3K. No, you have to be doing it one by one. So this one, do you understand what I just said? This one now 3,000. I think you've done something about pipe routing preference. You've done it before, right? So we are going to. I want to bring in the pipe that we are going to use to connect this thing. Now you know we finished the spacing of the sprinklers. So what is now remaining is the piping. So you can actually connect to a sprinkler. So sprinkler has threading. You know. Have you seen a sprinkler head before? You have seen it before. So that bulb, it has, you know what, this bulb we are using here, that's almost like a sprinkler because you screw it. So sprinkler too has a threading that you used to screw into the last rise. It's not even the anchor, the pipe that is dropping. Yeah. So that one can either be 15 or 20 mm threading. The threading of the sprinkler that is connecting to the last pipe. Can I draw it? They understand. Most of them are asleep. Okay, so what I'm trying to say is, if you have a riser like this, Abby, you know the one that is dropping, that will not drop to connect to a sprinkler. It's that this connector can either be 15 mm or 20, depending on the thread side of your sprinkler. If you're using 20 mm, you gain a lot of frictional loss. You now have frictional loss because the lower the pipe, the higher the frictional loss. Am I right?
Yes.
Is it the same thing with ducts?
Same thing.
Yes, that's what I just showed you, man. Should I show you one? No. So that's what I'm saying. So we have two types of sprinkler threading. We have the 15 mm and the 20 mm. So what I'm trying to say in essence is that 15 mm, you can use a flexible connector. Have you seen a flexible connector before? Because the reason why we normally use flexible connector is for coordination on site. You might have designed it that it should be at this space, this one that we have designed for. But site constraint, maybe there's a beam that they did not account for. That you cannot, or a big dog, God bless you, or there's a lighting. So what I'm trying to say is, if you have good marker, you have so the reason why we use that flexible duct, flexible connector is for portability, so that you can move if there's a, but it will still remain the main dropper will still be there. But the space where that sprinkler will now go can now move, can now flex, can go to this way, because of coordination on site. Do you understand? So this one will be 3K. Okay. So let me go and bring in pipes, system, pipes. So the pipe we normally use for firefighting is two types. It's either you use black steel, what did I call it? Black steel shadow 40, or you use CPVC, that is fire is fire resistant. Yeah. There's a name for it. So we have two types. We have, Blaze Master? No. It's a manufacturer, but I think they're the only one doing Blaze Master CPVC. Okay, so this is the pipe I'm talking about. Have you seen this thing? Look at it. Everybody, please check up. You see, what is it connecting to? Is this a black sea pipe?
Yes.
Who say yes?
It's orange pipe.
This is CPVC pipe. Now, Shebe, I told you that you can. Hello, is anyone talking there? So there are research that people have done as regard to comparing the flow. We are all mechanical engineers. We did fluid mechanics, and we did flow in pipes. We know that for every flow there is frictional loss, and that frictional loss is a function of the roughness of the internal area of the pipes. Abi? So the pipes that we are using here, if it is CPVC, people have actually done the calculation to compare with black steel to know which one has the more frictional loss and the one that has the low frictional loss. And they found out that CPVC is better, but it's more expensive. You'll be wondering that why is it more expensive than steel? It's very rough, very, very rough. In fact, if you leave it for so long, so much, it can corrode. Yes, if you leave it for so long, it can corrode. So this one doesn't have any. I'm not advertising, and I'm not saying you should buy CPVC, but I'm just saying that trends are changing. You should not stick our head to using steel every time. Steel is. So I prefer. So okay, I think one of the comparisons that they did. Look at this: steel versus CPVC.
Fire resistance. Can you withstand?
Yes, now you cannot. It's not saying for you to be using something that will be consumed
I mean, in
for far.
comparison with the steel.
No, they don't have comparison. That one is past. You get. So yes, now it's not propagating fire at all.
It's not fire resistance. Now it's a fire fighting.
Okay, so that's that. So now let's go and check the fire. I might not have the family for the CPVC pipe here, so we're still going to use our conventional black steel pipe. In fact, it's not even created here. Chai. Okay, please let me try and create my own pipe system. Let me create my own pipe system. Cast iron. Let me copy. Let me duplicate. Let me call this one. I duplicated it. No. Let me rename. I wanted to rename. Now call this one. Carbon. Carbon steel. SH. Music. Let's see. Sorry, I want to. So you cannot see the link because I searched SH. So I can now edit what I want it to be, material, color, all of that. Okay, so me, I'm not using cast iron. Oh, I'm using what is the closest? Who is saying CPVC again now? I said what you saw in that picture is not what me I'm using, but that's the new trend. Just to let you know. Do you understand? What we are using is our conventional black steel that you normally use for your chilled water system. It's still that one we want to use now. So this is still carbon. So heavy L2 and medium. Let me just use this heavy. Okay. What do I want my elbow to be like? What do I want my elbow to be like? There's no family for the elbow loaded here. That is. You said what? Let me use this one. Oh, junction. Let me use this one.
Hello?
Yeah, hello? Hello, who is there? Okay, so let's continue. Cross T. The transition. Oh, this CPVC. Let me look for my own. Let me look for my own families. Let me just go and look families, please. Let me load families. Let me go to fire protection material, fire protection. Let me go to sprinkler connections, cabinet accessory valves. No. Cabinet connections. Okay, so let me just use what is available now. Maybe branch. Apply. Okay. I want to try and load family of some five families. Unfortunately, my address is not showing. Okay. So systems. We want to start drawing the pipe. So the elevation of the pipe variably will now be which one is this? No, what level are we? 2750. This ground floor. Okay. My elevation is not, is it reaching that place? Okay. So we need to off.
Come up.
Okay, sorry about that. I need to put off anything related to HVAC. Have you?
Yes.
So which one are you? It's not on before.
But you know that what's you do
Okay, so I need to, so this pipe, yeah, it can be, let me just change it to it. I call it carbon steel schedule 40. The system is fire. You're not giving my system. So let me just duplicate one of the systems that's available. Let me duplicate. Let me rename this one. I say fire. I like underscore. Okay, firefighting underscores. Okay. So fire. So I would like to change the color to red. Okay, hope we know that the color red for firefighting is not just for feasibility. It's a code that is recommended by NFP and is strongly recommended that all fire pipes should be painted red. Carbon steel fire protection. The diameter is not even reaching 25, so I need to do another routing preference. So let me go to this. So routing reference. Let me start from 25. Let me start from 15. 15. I hope you are all following. I've created my, see, this is my fire carbon steel schedule 40. This is 40 mm. So I want to go to 25. Don't forget my schedule. I said from 1 to 2 sprinkler, you connect with what? 25 mm. When it's reaching 3, you use 32. It's a pipe schedule system. So now, what is the elevation? This one is at 7,000. Okay, so let me just I would like to align this to this, then move it close, move it very close, then press connect into. So it's giving me one or two error. Okay, so the dimension, because it's constrained, don't forget. Anytime you are seeing error like this on Revit, don't just click, you just say, this is not working. No, read what is in there. So I've constrained it with dimension before. Say, do I want to delete the dimension? I say yes. So I don't need the dimension. Now it's connected. So if you want to check the section, you might want to do it like this. Check this place. Then go to view. So this is my ceiling. This is my sprinkler. Sometimes they're using my type of system where I screwed with a latitude 440 10. You will not want to be using everything to be fine. You might want to put it at coarse or what is the third one? Or medium, so that it's not eat up your graphics if you don't have a very good laptop. But we thank God for. I'm not. We are not simulating now. I'm not sure the scope of this class reach that, but we can do it. No, the course here. Look at it here, so that if you are, I'm just saying this one is not my job. I'm just saying that if your system is not that good, don't go and be using fine every time because it will eat up your graphics and you might be stuck. So where are we? So you see, this is well listed to the ceiling, to the slab, and this is my what's it called? This is my elbow, and so you can actually make this to be a flexible connector. How do you do that? So let's go back to. Okay, so let me go back a little, go back. So I give it a distance, then I say connect with the flexible pipe. Then I select. It now asking me to delete the dimension again. Deleted. So I now draw the section again and check what is the difference. So you can come here. Sorry, please. You see, this is a connector, but it's not flexible. Do you see that? This is a flexible connector. So this flexible connector will give you the what's it called? The allowance or the vocabularies to go, you see. You are still okay. So this can actually happen on site when you have a constraint. You might not know, maybe this diffuser, the person that did this diffuser just said this 600 by 600. Maybe they want to say it, install it to be around there, and then you not be fighting. It's clashing. He said what? You can go. So the last time I checked, let me open something up. I want to disable sharing because I want to go to my hard drive. I might have some things that I don't want people to see there. It's not flexible, doctor.
I know it's not flexible,
I'm coming, please. I'll show you. Yes, so who among you here know more than 2 brands of firefighting equipment? Who knows one? Or one? Blaze Master, they do pipe alone, just pipe. They don't do any other thing. You've tried now. It's a brand of firefighting. Lombardi, that one, now PPR, baby. NAFCO, God bless you. Is there any other person that knows something else? So we have SRI. We have SRI. We have PICO. We have Shield. We have. I can't find SRI here. I think I don't have it. I don't have it. Chief. I used to have it before. But wait, So this is the catalog. Someone want to speak? Let them speak. Allow them to speak.
Sorry, you can't see your screen. I think this is example. You can't see your screen.
Sorry, you see it now. I did that intentionally before, but you'll be able to see it now. Can you see the screen now?
Yes,
So
sir.
there's a limit to this flexible pipe. There's a limit to which distance it can flex to. You get I'm looking for the catalog. But unfortunately, I don't have it on my hard drive here. Maybe next class. Next time we can maybe is this our last portion of the course? Okay, so tomorrow I might bring the catalog of SRI. So we are going to see to what extent can it go. Okay, okay, that's that. So, but to make our work faster, I would like to disconnect this flexible and use pi. Okay, so you can connect into, look at it. Do we even know that Revit can generate? Okay, let me tell you. Revit can generate route for you.
Yes,
You have to delete delete all constraints. Delete this one too. Now let's say click. Okay, why are we having two here? View range 3000. Okay, let me look at it. This one is hosted to level 0. Okay, it's 26. This one is hosted to level 1 at 26. So why am I seeing it? View range. Okay, 3000 is too much. Let me use 2 8. I think it should be okay. Oh, it's not okay. Let me use 2700. Okay.
Engineer, you want to see only the level 1, right?
Yes.
You can change the from the view range, the depth view.
No. So that's not what happened.
Okay.
Yeah, what happened?
So initially when you were trying to place the sprinkler heads on this level, you were doing it manually. Then eventually decided to copy and paste from another level. So the few ones are the ones that you were manually positioning before. So you can delete those ones manually. So that was what happened.
Oh, okay. Are you sure? Okay, wait. Let me just confirm. Let me see. Okay, I think you are right because it's not showing here. See it. What I clicked here is not showing here at all. Oh, you are right. Okay, so let me delete this. 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 So let me go. Okay, I think. Okay, see, yeah, you are right. Thank you, engineer. So let's go. Let's go for the automatic routing. Yes, I wanted to route it automatically. Is this place supposed to be sprinkled? Is this place covered? Did you, when you were doing HVAC, did you cool this place? This front entrance, you could it. Okay, so let's move backward a bit. Okay. This one should go. This one too should go. This should go. Okay, so you pick one of the sprinklers. It's going to give you. Okay, you pick more than one. Sorry. Let me just pick everything on this floor. Let me pick everything. Select all visible. Then you now say, why is it not giving me automatic routing? Okay. System, pipe layout. Okay, this is too much. Real range 3000. Okay. I think. Sorry, please. It's been a while. I select visible. It's not giving me that option again. I don't know why. Let me just create similar. Why? Generate automatically. Okay, I think I've gotten it. Cancel. So it has to be in a system first. So let me select everything. Sorry, please. Select everything. Okay, I think the one that is causing that issue is this one that is already in the system. So, I'm going to replace this. So, yeah. Generate layout. Let's see. This is it has generated some layouts. Do you see it? It's generating some layout, some route for us. So you can decide to make it a network. You can decide to make it perimeter. Do you see it? Do you see it? So it has a lot of options. You can go like this. You see, this is another option. This is another option. This is another option. So which one do you want us to go for? So let us go for this one, this perimeter. So you say finish. It's going to generate it. But Revit is not that intelligent because it's not going to do your engineering for you. It's just going to make your life a little bit easier. You see, it has generated the route. But the pipe sizes, I'm very much sure that it's not going to be correct. Let's check it.
It would be around, say, I'm seeing some vibes there. And it's in front class, I have the compass. School car. And so,
They are not connected. Abi. This one is okay now. Look at it.
no, okay, yeah.
They are connected. Everything will be connected. It's just the pipe sizes that is not. I think this thing is something we should always look after, especially when you are doing things that are very, very voluminous. And you are just maybe wanting to send a scheme design to your clients. You don't have to stress yourself to be blending the pipe diameter, doing it. Just do this one. Let them know this is the route you want to follow. You get. So this is what we are. This is where we are going to be stopping for today. So maybe tomorrow. Oh, okay. So sprinkler and toilet is a little bit dicey. So it is not actually stated that sprinkler should not be put in toilets, and it's not did not even say that you should not put it. So it's based on your own discretion. But because all toilets is fitted with smoke detectors, you get. So anything that is going to cause fire is going to be detected, and because most toilets are wet, they are wet toilets. So I don't think is really prone to fire like that. So most of the time we just ignore fire sprinklers in toilets. However, if you are doing a dry toilet, I've not seen it before, that's very prone to maybe fire or something, you can decide to put it. I've put sprinkler in a toilet before. Is there any other question? Yes, now. 5 meters as in, I don't understand. 5 meters squared in the area. I've not seen that code before. Can you please confirm me? I've not seen it before. You know, which we have been discussing code here before now, but that one you just talked about, me, I've not seen it before. If you can just refer us, we are all here to learn, Abby. I said it's a little bit not straightforward.
It's discretionary.
That's what I said. It's not straightforward. It's because most toilets are wet, and we are going to have smoke detectors there. So anything that is going to cause fire there, you have seen it. And if the fire is so much, you will see water to quench it. But if you do not get a wet toilet, you are designing a dry toilet. Me, I've not seen a dry toilet anyway. So if you have a dry toilet, so
I think it's just a common sense that there is most toilets are not prone to fire incidents. We have not seen a place where they say fire starts from the toilets.
You understand?
It's not possible.
So, and why do you design fire? Is because you are looking for processes of things that I know you must have discussed all these things. There must be a combustible material and other process.
So what is the combustible material that's in the toilet? Except that someone goes there to smoke. And if you go there to smoke, there's already a smoke detector. That's what I'm saying. So they will catch you. No matter what, they will know that you're smoking there. So
Maybe the lights there can catch fire.
it's
The lights bulb, light bulb, can it catch fire?
possible now.
I'm not saying that the wires.
So, like I told you, that if you're doing automatic networking of a sprinkler system, like I just did now, be wary of what? The pipe diameters. It's not going to be correct because the Revit is not that wise to know where your zone control valve is. Do we all know what a zone control valve is? A zone control valve is what you use to isolate. So this is a zone control valve. See it. So it's an assembly. So it is what you use to separate the amount of water that is going to isolate a zone completely. Just like you have zone that you have automatic zone that part, you have alpha like that. That controls water cycle. So that can isolate that open door. So this is the one channel I was talking about. So this is the control valve. Okay, no problem. Yes, now look at what I did the other time. Okay, so he asked, someone just asked that, do sprinkler have individual flow rate that differs from one another? And I said yes, because flow rate, as far as sprinkler is concerned, is a factor of a formula called Q equals to K, which is the what's it called? K factor multiplied by pressure square root. So the amount of pressure is directly proportional to your what? To your flow rate. Do you understand? We are still going to do this extensively tomorrow. So Q, which is your flow rate, you can determine the flow rate of your first pressure. Okay, maybe we should just go there, Sha. So like I was saying, let's just take this one as a sample. What is this rectangle representing? Please, I want you to be active. Don't sleep. This one, this rectangle here, I mean the square here, what is it representing? The assumed maximum area of operation, AMAO. So the amount of sprinkler that is in that area will now determine the amount of sprinkler you are going to consider for your what? For your calculation. Because you cannot be doing 20-story building now and you say you want to calculate for every of the sprinkler. Is that how you die? Or something else happen. I'm just saying that is why engineering is very logical. Something that is not possible, they will not ask you to do it. It's not possible. So what we have done is that we assume that the sprinkler, we even to be honest, I just demonstrated a video to us now. We saw that it's not all the sprinkler in that zone that is working at the same time. But in this our maximum area of operation, do you know what it means? It means that all those 20 sprinklers we are considering are working at the same time, which is very rare. Oh, you don't understand. Because we normally consider worst case scenarios. So the maximum area of operation means that the sprinklers, all those 20 sprinklers in that area that you just mapped out. How many sprinklers did you map out in that place? 4. Is it not 4? For the second one, you know I did 1 before. Yeah. The second one that we're doing is just 4 now. So those 4s are working at the same time. So that is the worst case scenario. So you are not going to consider that those 4. You are not going to say S4, or you can say S1, S2, S3, S4. So you now say this S1, you want to calculate the first flow rate. You're not going to consider it by saying Q, which is your flow rate you are looking for, equals to your design density, which is 5 mm per minute. Do you remember? Okay, let me be typing it. Q equals to design density multiplied by what? Multiplied by our area per sprinkler head, which will now give you something in what? Something in liters per minute. Do you understand? See, as an engineer, you must be very versatile with your units. Unit is very important. Very, very important too. Okay, who is that? Who's asking? Okay. What do you mean by size? Yes, like I told you before, I said if you have a common header, you know, from that common header, you'll not be having drops. Abi? Those ones that are dropping is either they are 15 mm or they are 20 mm, according to the sprinkler threading you are using. You get, so you can either be, unless you are saying something else that me I don't understand. But if I want to assist you, there are different type of sizes of sprinkler. We have the bulb, that bulb that ruptures. So we have 5 mm bulb, we have 3 mm bulb. Orifice too, it differs. You get, and well, the area that it cover does not differ per se. What makes it be different is your pressure. Do you understand? Your residual pressure. If it's just that, okay, let me show you something. I pray I see what I'm looking for this time around. Let me just look. I don't want you people to see.
Stop sharing the screen.
Okay, wait. Okay, I should stop. Please, I want to stop sharing my screen for a moment. Stop sharing. Stop. Abi? Okay, sorry. So I want to show you a typical discharge pattern of a sprinkler. You will now see that it varies. You know, when you are doing inline fan in HVAC, you normally see external static pressure to the flow that it can do. At a very high external static pressure, the flow might not be as much as when the external static pressure is low. So also is the sprinkler. When the pressure is very high, you might not, you will have a lot of discharge. You have a lot of, just like pump, everything varies. I will show you, don't worry. What am I looking for? Sprinkler. God, I have sprinkler again. Catalog, come on. Catalog, sprinkler. Okay, thank God we found one. Okay, so this is spray pattern. These are spray patterns. So this spray pattern is for a particular brand called Tyco, Tyco. Is a manufacturer of sprinkler. See it. They are telling us now that at zero, what is this? You see, I told you that 0.5 bar. That is the minimum. Okay. Now they say, which one should we even use? Should we use feet or let's use meters? So they are telling us that if we have a 0.5 at 42 liters per minute, do you see? What is this at the down part of? Sorry, please. One. Okay. Okay, so this one is not even what I'm looking for, but let's just say this one. So it's a 50% flow inside, 50% flow outside. So this one is 50% flow here. This is not what I'm looking for actually. Let me look for another one. Let me look for another one. Sorry. So these are sprinkler head though. These are the products. So let us just go through them. So these are to your question. You said, does the coverage differ? And I say we have two type of coverage. We have extended coverage and standard coverage. Standard coverage, when you are able to meet their own minimum requirement of pressure, it will give you that discharge that you want. It will give you this discharge that they have specified here. This is their catalog. That's the spray that is going to give you. Once you're able to meet their minimum requirement, you see that this one is 1 bar. You see that the requirement for this one is 1 bar. That the list, that you are not even having any residual pressure at all. You should have at least what? 1 bar for this one, so that you'll be able to achieve this spray pattern. Okay. Now let me go for another one. So there are some sprinklers that are fitted with guard, especially in warehouse where trailer can enter, so that trailer is not going to crumble when they are bringing trailer that is higher than the normal conventional one that they used to have. If the height is high, so it's not going to crumble the bulb. So they protect it with all this. Look at this. These are guards. You see, it's sprinkler guards. So these are the technical data. Look at it. The K factor, like I told you, this is liters, 60.5 liters per minute, 4.2. This is another unit. So the tread side is 1/2 inches, which is what? About 15 mm. So the spray pattern is what I'm looking for. If I cannot find it, but what I'm just trying to let you know about the spray pattern is it's a factor of your pressure. If you're able to meet the pressure that they have specified for you, you will get that discharge that they told you. This discharge pattern that they have actually specified. Oh yeah.
Maybe this class bigger than the other. Is it like the fluids of those sprinklers or what? You know, like now for sheep water system, our windows now, I mean, a particular brand. So what they call the water flow rate, initial capacity. When you have a bigger capacity, you know that the water flow rate for that particular capacity bigger than the one you get my point.
So I like people that relate things a lot. You start from what you know, you relate it to what you don't know. I like the fact that this guy is relating what he knows to what he doesn't know. So it's the same thing for sprinkler too. Sprinkler that have extended coverage, that they can do more coverage, they require more pressure and they require more flow rate. When I'm having, I don't know, maybe this would be good to share again. Let me.
You should come for the firefighting class.
Okay. Okay, look at what I'm saying. Look at what I'm saying. So when I'm having 1 liters per second here, if it is an extended coverage, what you'll be having here will be like 1.9, 1.82 2 liters per second. Do you see the difference? Like times 2. And actually, it's going to impact your pump size. It's going to impact your pipe sizing. It's going to, now, the funny thing about it is that you are now going to need fewer sprinkler heads because that one will now do more coverage. That's why they call it extended coverage. But a standard coverage, we do all this normal one that we have done. For extended coverage, that one is different. The flow rate covers a lot of ground. It covers a lot. So you check the discharge pattern. Sprinkler is a lot of engineering, you know. Please don't.
The thing is that actually limited ourselves, okay, maybe based on design, it's also numbers of sprinkler in particular. So why I actually asked one question was because, you know, in an area now, maybe it has to be, you know, in our former work, for example, two sprinkler, one sprinkler for maybe 21 square meter. So maybe the next space is now around 29 square meter area. So is it that we can now use maybe and still want to maintain one sprinkler in that space? Is it that we are not going to a bigger site? That was why I was asking that question.
Oh, okay.
That maybe be able to cover those areas and at the same time.
So I like that question. You know that we have considered the list of consideration for our office space that we are designing. Because after light hazard, there's nothing less than that. And yes, so any other thing you want to do is, because the more you increase the capacity of your sprinkler coverage, the lower your hazard level. Do you understand? When you have 30 cubic, if your sprinkler can do 30 square meter. That means that sprinkler you are going to be needing in 100 square meter space is going to be 50.
Yes.
Do you understand? That means you are not considering hazard at all. The hazard is very low.
I say the more sprinkler, the more.
The what?
Continue sprinkler, the more safety factor.
That is it now. That is what they are saying now. They say if the high hazard, they say you should consider one sprinkler to have 9 square meter. And you are using 100 square meter space. You are going to have more sprinkler in that place now. You are using 9 square meters.
At least 10.
So we have used the list of 21 square meter. So if you're having something like 29, you have to use 2. Do you understand? I don't know, maybe what I've said is clear, Sha.
Based on the level of-
So the level of the space we have used to design this our project is the list of coverage you can have, is the most coverage. Like when I say list, I mean the least hazard.
And that was what actually brought the question.
You cannot vary the hazard in their office space. You cannot have office space hazard one, unless if they are doing different things there. Maybe in this office space, they are just reading and maybe using laptop. And in another space, maybe they now have these as they have documents that they don't even want to risk it burning at all. Then you can now increase that hazard to maybe ordinary hazard 2. Maybe in the kitchen now, you can now increase that one to ordinary hazard 3. Maybe in their pump room, maybe where they have fire pump. You know, you can also sprinkle fire pump. Fire pump can sprinkle it. Fire pump can sprinkle itself. So that's so in the pump room where you have fire pump, booster pump, filter transfer pump, STP, all of that, you can also put sprinkler there, but that one cannot be high hazard. So you now have more sprinklers in that place. But in the same office space that they are not doing any, it's still open office. You just partition it. Why do you not want to say this place is light hazard and this place is ordinary hazard? If I'm your client, I will ask you that why is this place light hazard and why this one ordinary hazard? What will you tell me? If I'm your client. So you have to consider everything. If it's the same function, or if they're doing the same thing. That's what I said now. I said in a place where maybe you are doing this office, so you have a lot of paper, you have a lot of files that you cannot even risk it to get burnt at all. Maybe history, I don't know.
Yes. I think according to that, I just wrote that.
You say what? Which one? BS. BS.
Okay. So out of that, like I said, you can vary.
Yes, you can vary hazard in a particular space depending on what you are doing.
You can vary hazard on that. Whereas, for you to classify a building according to that, single square area of space, that's how you can classify it. So that's why I would ask if I didn't get that very well. So that's what I was saying.
Can I answer? Okay, so when you want to classify a building to a hazard, you don't just look at what is happening here. You don't just look at the spaces. You look at activity, look at occupancy, look at storage. In fact, some places, when we were doing National Theatre, we even sprinkle the ceiling void. I'm very sure you might not have heard that one before. Sprinkling of the ceiling void because of the fact that the code says when the ceiling void is more than 1.5 or 1.2 meters, you should sprinkle it. Especially when you are sprinkling the space below it. It is the same thing. You should sprinkle it. So it's not just, you cannot classify the building alone as an okay. Okay.
So according to the size, according to the size, according to the calculated size, that's our fire pump.
Yes, now it is our residual head that the pressure loss, the eventual. You can vary now in a building where they have different activities going on. You cannot say the hazard level of an office space is the same hazard level of the kitchen in the same building. They have the same, they share the same building, right? But the activity and the occupancy is not the same.
Sorry.
Do
You are trying to say if I have the money, I can make all of them decide. Is that what you are trying to say? If you say that, it's also okay. So I can use this scenario here now. It's more like if they are playing children like that, and if they are putting here, where is more likely to have as like where they are putting at it. So that means priority on hazard or high hazard will be on this. It's just like normal. So I feel also I don't do firefighters. This is my first class. So to deploy manage risk. It's not like also manage risk. You're not saying the design of putting in an hospital or in the operation room is the same design of putting on the corridor or in the place people are sitting down. They will different equipment. I don't even understand it. So that's why to me it's logical that a building, they said the building is having the same functionality throughout. But if there's different functionality, the hazard can change per space. And I think that's the part.
So let me tell you, so
Select something.
yeah.
But people are that use space K for 115K. To select the which is according to determined, because you have to determine design first. Before you have come and now, okay, this is other hazard too. You don't spacing of speaker that we are going to use in this space. You cannot just, for me, I feel you cannot fail it.
That is what you think you get. Let's check what the standard says. But the
it's not. Let's not so that we don't. Because we are recording something, we don't waste time. See, interpretation of code varies.
Yes.
Interpretation of standard varies. Like, let me give you an example because I know you do this. References are listed. So people will tell you that if you use a particular code, actual code, tell you that the minimum fresh air you can have is certain value. There was a time we wanted to do one project together that those people said we should go and use the British standard of ventilation because they believe that one needs more airflow than actually the communication and other things. So even that actually, the interpretation of code varies with people. You understand? The interpretation of the code and the understanding of the interpretation is what we now have to check. You can say that, and again, I think another thing that I also want us to, which is one of the reasons why I'm doing what I'm doing, I also want people to understand is that don't go by what people tell you. No matter how experienced they are, find it in a book, check it, read it. They might be wrong. And read them because it's the interpretation that I've related with him, I've related with a couple of engineers, and I noticed that we do things by not the best practice, by what somebody, the person that taught to. By telling her what is the cooling pattern used for if you are doing say 0.2. And we have all become now 0.2 engineer. You understand? So it's you for you to read the code very well and understand it and be able to interpret it in the best way possible that you think what the code is saying. And there are things in code that can be argued.
That's not straightforward.
They are not straightforward. So
they might not talk explicitly for you. Yes.
So what now determines what you do as an engineer is maybe sometimes when I want to do certain things that I think are not that I'm not quite comfortable with, I look for experienced people. Have you used it on the project? How does it work? Then I now have to work by experience of people or what they have said or what they have done or what has worked for. It may not even be somebody that is my superior. It may be someone like you that has done that kind of project before. You understand? So for me, that's it. Let's not be arguing what code says and what code doesn't, so that we can
go ahead. Sorry, we can have that conversation later. Yeah? Okay, so I said
yes,
if we are going by calculating the flow rate of the most remote sprinkler, which is going to be our first sprinkler that we'll be considering here, is either we arrange it in ascending order or we are arranging in descending order. So if we are going by this our own project, this office project, okay, so we can just say, okay, so this instead of making it S40, it not be S4 or S1. Which one should we use? Let's say S4. Do you know why I'm saying S4? Because we are considering just 4 sprinklers. My people, are you no more with me? Chai. Okay, let me go back to where I got before. Okay, so we are doing light hazard, isn't it?
Yeah.
We measure out 84 square meter. How many sprinkler did you get? 4. Do we understand?
Yes.
So we are using 4 sprinklers as our maximum. So this is S3. So S4, we want to calculate the flow rate on this S4 now. So how we're going to go about it is we go back to our code. It said minimum density, design density in mm per minute is 2.25. Please note it, 2.25. So we now go back, we now say equals to 2.25 multiplied by what's area per sprinkler head. What did you get? Area per sprinkler head for light hazard, 21 meter squared. Meter squared. 2 point.
Millimeter.
You said what?
25 millimeters. So
Okay, I should put the unit of it. Mm per minute.
That's for meters.
No, we are not. They have already done it. Yes, don't worry. Wait, I'm coming. I will tell you the reason now. So this design density is not just in mm per minute, it is in mm per minute per liter, but they are not putting it right. Wait, let me show you. Where can I also show you this? It is wait. Let's just continue, but I'm sure that we don't have to convert it. Just let's continue. So what will not be the Q? Who can help us do it? 21 multiplied by 2.25. 2.25 multiplied by 21. So our flow rate in liters per second. Okay, I think the reason why it is no longer converted is because we are getting our units in liters per 47 point what? 25 in what? Liters per minute. So I think this unit has done a lot of conversion in it. You can try it, but if you try it, you are going to get this. Is anybody trying to convert it? You try and convert it. Okay, so it's 1,000. So it's what is making it to be the same now. So we now do another one. We do another one. What we are going to do now is do Q equals to K, then P raised to power of half. How do I make this one raised to power of? Subscript. Superscript. Where is the super?
look at it. Somewhere at that spot.
I've done it. I've seen it. Thank you. So look at it too. We have 2 formulas for the calculation of our first flow rate of this first sprinkler. So the first one was 47.25. Everybody can see my own screen, Abby? Okay, now let's go. This will now be equals to what is our K factor of the sprinkler we are using? Because I told you that we are using 80 Abby. 80 multiplied by what is our residual pressure? 0.5. Then half of it. That's raised to power. No, raised to root, raised to the power of half. Root.
Yeah, maybe that give us some time. Let's have a
Okay, we are going to stop here. Okay, I think I've been using superscript to write everything here.
Let's give us answer.
Give us answer. Let's just give us answer. So that's what I'm trying to do now. So 80 multiplied by 0.5. You said it's what?
56.5.
56 point. So you see that the flow rate are very close. So we are not going to choose the highest.
You must do the 2 method.
Yeah, that we are going to, we normally do two-way verification. Because if it's first one,
I want to see where my friends are. These guys.
so you see now, so we're always doing these two verifications. So is that how you, if you go by this one, that means your flow will not be that much. Then this,
How do you know that this option is not too
is not.
much?
How do we know that what is not too much use? It's not here, oh, it's water. Oh.
Not so high.
It's not so high because it is the K factor that is recommended in the catalog of the manufacturer of the sprinkler that we use. And we also use the minimum flow rate, minimum pressure, is the residual pressure of 0.5. That those two things will make you. But if you are using something higher than 0.5, you are going to get more flow rate. You understand? So when you use the lowest flow rate and the recommended K factor by your manufacturer, you are going to get the exact flow rate you need for the first sprinkler. We understand.